Hi guys, welcome back. So we're going to finish up at lesson 2.3 by working on the even problems today that we skipped over. So let me present my screen and we'll get started on that. All right, let me scroll up. So working on the even problems today. Okay, so let me, just to give myself more room. So we're doing problem number 2 today, okay? So problem number 2 tells you that your vertex is at 0, 0, your focus is at 0, 1. Remember, I'm not using the distance formula because I think it's easier just to graph and talk about the answer. All right, so let's plot the vertex at 0, 0. Oh my goodness, not again. Try that again. Okay, plot the vertex at 0, 0. Guys, I don't know what is going on. 0, 0. And the focus, you know what? I'm going to make my grid bigger. So I'm going to delete this again. Go to my mouse. Make this bigger. Okay. So my third time, maybe third time's the charm. Vertex is at 0, 0, and your focus is at 0, 1, which is just above right here. Oh, goodness. Okay. Again, I don't really care how wide the parabola is. All right. I do know that the focus has to sit inside the parabola. So that lets me know that my parabola is opening up like this, some way, shape, or form. All right. So if it's opening up, my equation is going to be y is equal to 1 over p 4p x squared. And p is positive because parabola is open up. Okay, if it opens up or to the right, it's positive. So the p-value, remember I keep saying the p-value is how far away the distance from the vertex to the focus or from the vertex to the directrix. Well, there's 1 unit between the focus and the vertex, so p is equal to 1. So I plug 1 in for p and it becomes 1 over 4 times 1 x squared, and then just clean up by multiplying. So y equals 1 over 4 x squared. Okay, and that's it for that problem. All right, so let me trash that, and I'm going to do just to get back to my, okay. So we're working on evens today. Let's go down to problem number 4. So remember for these, we want to graph them. We want to talk about the focus, directrix, axis of symmetry. But the first step is to always get your variable that is not squared isolated. So in this case, I want to isolate the x. Okay, so I have negative 5x plus 1/3 y squared equals 0. Equals 0. Isolating the x, I'm going to subtract the 1. I don't have any words for why this is happening, and it's very frustrating. All right, let's try again. I'm going to subtract 1/3 from both sides, 1/3 y from both sides. All right, so I have negative 5x is equal to negative 1/3 y squared. Okay. Then I'm going to divide both sides by negative 5. For this problem, instead of dividing by, I'm not doing this to distract you guys. I don't know why that's happening. Instead of dividing by negative 5, you can multiply each side by the reciprocal. Okay. And that makes more sense in terms of this problem since we have a fraction on the other side. It'll be easier to multiply by the reciprocal. All right, so I'm going to multiply both sides by -1/5. -1/5, multiply both sides by. -1/5 times -5 cancels, so I'm left with x is equal to, negative times a negative is a positive, 1/3 times 1/5 is 1/15 y squared. Okay, so that's the equation, which I'm going to write over here and then erase everything else. So it's x is equal to 1/15 y squared. X is equal to 1/15. X is equal to 1/15 y squared. Okay, so if I think about x is equal to 1/4p y squared, that'll allow me to solve for the p-value. Okay, so remember you set the 1/15 equal to the 1/4p, and that allows you to solve for the p-value. All right, so I have 1/15 is equal to 1/4p. I'm going to cross multiply. So I have 15 is equal to 4p. I should make sure I didn't lose a negative. I did not. Correct. Correct. Okay. $15 is equal to 4p. Divide both sides by 4. And you have p is equal to 15/4. Now again, even though typically in math we say leave it as an improper fraction, for graphing purposes, it's going to make more sense to change this into a mixed number. So that is 3, 12, 13, 14, 15, 3 and 3/4. Okay. So keep that in mind as we talk about like the vertex, the directrix, the focus, the axis symmetry, and all that stuff. So the vertex, when we go to graph, the vertex is 0, 0, because there is no h and k values. All right. The a value, remember the a value tells you it opens up and there's a vertical shrink by 1/15. So it opens up and there's a vertical shrink of 1/15. Okay, we're going to talk about the focus, the directrix, and the axis of symmetry when we graph. Okay, so let me, oh, I didn't mean to delete all that. I wonder if I can undo. I don't think I can. All right, I got to write some of that stuff down again. Sorry. It was x is equal to 1/15 y squared. We said our vertex is 0, 0. And we're still going to talk about our focus, our directrix, and our axis of symmetry. Okay, that's all I'm going to write for now. All right, so let me just make my grid larger so I can actually graph accurately. Let me do this one actually. All right, so we're going to plot the vertex at 0, 0. Now we said, remember, it opens sideways. It opens to the right because there's a positive a value, okay? And, oh, that's the other thing I need, the p-value. We solved for that already. What did we say the p-value was? -15. No, I forget what it is. 15/4. 15/4, which we changed to 3 3/4. That was the other information we needed. Okay, so your focus and your directrix are 3 3/4 away from your vertex. So I'm going to go 3 3/4 away this direction and 3 3/4 away this direction. Oh, goodness. All right, now because it's x equals, I know it opens sideways, And it opens to the right because it's a positive lead coefficient. So I know my parabola is going to open this direction here, right? If I was just sketching it, I would just draw my U. But since I do want to try to be a little more accurate and I want to explain to you how to graph, we're going to talk about that 1/15th. Remember we said is a vertical shrink of 1/15th. Now you have to kind of envision your parabola opening sideways and that parent function, that typical pattern we talk about. From the vertex, we would go out and then up. I'm saying up even though I'm moving to the right because your parabola is sideways. So as far as this parabola is concerned, going right is going up along the parabola. So normal pattern would be out 1, up 1, right? Out 1, up 1. Then it would be out 2, up 4, out 2, up 4, out 3, up 9, out 3, up 9, out 4, up 16, and so on and so forth. But I'm only going 1/15th of the way. So it would be out 1, up 1/15th. Right? Then it would be out 2, let me plot the other point. Then it would be out 2, instead of up 4, you're going up 4/15ths. Then it would be out 3, instead of going up 9, it would be 9/15ths. Sorry guys, just ignore all the craziness. Then up 4, out 16/15ths, which would actually be a good point to plot. Let me erase some of this. Okay, so if I go, what I say, out 4, oh, my goodness, it's very frustrating. Out 4, okay, I'm just going to sketch it because there's no hope. This is a mess. This is a mess. Don't worry about the actual graphing because I can't do that right now. It's not allowing me to. So here is my vertex. Here is my focus. My vertex is going to be super wide. And then my directrix is aligned like that. Okay. All right. So your focus, where is your focus located? Well, to get to your focus, you move to the right 3 3/4 and up 0. So 3 3/4, comma 0. And again, if you wanted to change that into 15/4, comma 0, you could. The directrix, well, you're going to the left 3 3/4. So that's negative 3 3/4. And it is a vertical line. So it's x is equal to negative 3. Negative 3 3/4, and its x is equal. That's your directrix. Okay, that's your directrix. And then your axis of symmetry, your axis of symmetry is the x-axis, or y is equal to 0. Y is equal to 0, your x-axis. All right. All right. Sorry, guys. I don't know. Like I've been saying, I don't know why my little pen thing is going crazy. And it's very, very frustrating. And okay, the next one, write the equation of the parabola shown. Okay, so for this one, your parabola is opening up. Its vertex is at the origin. So I know I'm going to use y is equal to 1/4p x squared. Okay, your p-value is positive since it's opening up. How many units is the vertex away from the focus? It's 5 units, so p is equal to 5. So you just plug 5 in. Y is equal to 1/4 times 5 x squared. So y is equal to 1/20 x squared. That's your equation, right? That was number 6. Number 8 will be the last one. It's opening down, all right? So since it's opening down, I know my p-value has to be negative. Its vertex is at the origin, so there's no h and k values. So my equation I'm going to start with is y is equal to 1 over 4p x squared. All I need to do is figure out the p-value. All right, how far away is the directrix to the vertex? It's 3/5 of a unit away. P has to be, here we go again, going crazy, not even doing anything. I don't know what's going on. P has to be negative since my parabola is opening down. All right, so since my parabola is opening down and my P has to be negative, I'm going to plug in a negative 3/5 for P. Y is equal to 1 over 4 times negative 3/5 x squared. Bring it up here to do the work. So I'm going to have oh my goodness, guys, this is so incredibly frustrating. Y is equal to 1 over, what would that be? Negative 12 fifths x squared. 1 divided by negative 12 fifths is the same thing as 1 times the reciprocal. 1 times negative 5 fifths. So it's y equals negative 5. I said 5 fifths, I meant 5 twelfths x squared. And that is it for number 8. We survived. And I apologize again about the craziness of my pen. I don't know what is going on. All right, that is it for lesson 2.3. I'll see you back here for the next lesson. Bye.